Hey everybody, so today we're going to look at Dynamo and creating a curtain system on a mass. This workflow came about because there were some users that wanted to apply or visually see ceilings in a certain way, and that wasn't you couldn't do that within Revit natively with the ceiling tools. So this was a kind of a workaround to achieve that. And it works pretty well. And even if this doesn't apply to your specific use case, I think there's things that you can pick and choose and pull out of it and apply it to your scripts. You can also leverage this just to learn the flow of information. So this isn't a fancy presentation. We're not going to be zooming into things and looking at them. We'll just jump into Dynamo and kind of look at it that way. I won't go into the individual nodes. I will talk about the groups and kind of what's going on there, and then we'll run the script and kind of see what happens after that. But I do recommend jumping down into the description part of this video and looking at the OneDrive, and you'll find all the scripts in there. That goes for this script and any of the other scripts for my videos, and other shareable content is in there as well. Check that out, because I think for learning purposes it'll really help you out if you just open up this script. And I'll share the file that I'm working on as well. And if you open up the script, you can run it and kind of see the flow of information. I think that's incredibly powerful for learning purposes, and then you can kind of see that and play with it and switch things up and see what happens. So definitely take advantage of the script and use it in any way you want as a starting point, or if you want to use it on a project, go ahead and take this and do that. One cool thing is this script doesn't have any packages, so you should be able to open this up in Revit 2020 and you're good to go. So this is before this script. I've got in the Revit model, I've got just some closed spaces with ceilings, and what it's going to look at is it's going to look at those ceilings, and it's going to create the curtain system. You can see here after it runs, this is the curtain system, and I'll talk about why we see this down here in the corner. It's kind of cut off, but I'll talk about that, and then we'll talk about this point and then this center point briefly. So let's go ahead and just jump into the script, and then we can kind of look at those things. So first bit that the script does is it gets the specific ceilings that you want. So in this case, we're looking at a wood slat ceiling. The reason why is because the projects that we're using this on, they had a temporary ceiling in place for this type of ceiling. And so we're able to just filter out and grab that specific ceiling and then apply this curtain system to it. So the other part, the first part, is just this, and this is just the curtain system that you'll be using, which in this case is a 5x10, and the model that I give you will have that. So, so that's all, and that's all the user would be required to do, as long as you knew what the temporary. If they don't, then they would need to update this as well. This code block, and then this code block down here. So the next bit, and it's a combination of this part 2, and we'll talk about that in a second, but what this does here is it gets the ceiling size and placement point, and so it figures out the geometry of the ceiling, and we get the thickness, and we figure out kind of the center point of that information, or figure the center point, and then after we know the center point, then we kind of know the thickness, and we can figure out how far the curtain system needs to go up or down based off of like the curtain panel size and the curtain panel thickness, And so if we just factor in the geometry of the ceiling, the geometry of the curtain system, we can figure out kind of the where it needs to go in space. And really all we're doing right now is we're just figuring out how to place the family. So that brings me to this other part, which is creates and places families at 0, 0, 0. So what this does, based off of how many ceilings you have, because in this case we've got 1, 2, 3, 4, 5, 6 ceilings, so there can be 6 different shapes. So we couldn't really use the same type of geometry or the same type of family. So in this case, we create 6 different families. And so all this does is it gets a count, a list count, and then it does a sequence, and so it counts up, and then it just names ceiling temp underscore 1, 2, 3, 4, 5, and that's our name of our family. And then the geometry for this family is the element geometry of the ceiling. And so this is our family that we'll be placing. The reason why we have to do all this weird stuff with points is because when this geometry, this element geometry, goes into the family type by geometry node, it places the geometry kind of in the upper right corner, and depending on the size of the geometry, the placement point could be different. And I was worried about, okay, if it's here, like how do I figure out where that placement point is always, because it could be different depending on the geometry, and it's different in space. So what I do is I just place it at 0. I place all instances at 0. Then I figure out the centroid of that geometry, and then I just figure out the difference. So this is at 0, 0, 0, each instance of that family, and then the center point is offsetted somewhere based off of that geometry, the center of that geometry, from 0, 0. So I just take that value, which, for example, we could have a square. The insertion point's at 0, 0, 0, but the center point is at 22 in the X and 22 in the Y, or something like that. And because we started at the insertion points of 0, those values of X and Y are what we're going to use to deduct from the actual real geometry that's in the model. So that's why we get the center points of the real geometry, the real ceilings from that model, because what we can do is deduct this difference, we can subtract that difference, and then figure out the insertion point of this ceiling for every single thing in real space. So we can figure out the insertion points of everything in real space. That's all this does. So it says give us distance from 0 to X and Y, which then can be subtracted from the current location, which gives us the correct insertion point for each of those 5 ceilings or 6 ceilings. A bit confusing, and if you sit down and just run this script, which we will come back to this, run the script and see how this flows, it'll make a lot of sense. And then from there, what we do is there's some pass-through nodes, because it deletes some existing geometry, and then because what this one does is it deletes the, you can see here it passes through the first instances because these are irrelevant. We're only using these placed instances of the family as a way to grab the difference between the centroid and the insertion point, which we use to subtract from the actual centroid in real space to figure out the insertion point. So we delete that geometry, which isn't necessary anymore. And then we move on to the family instance by points, and we actually place it in the real space and in the model. And then from there, what we'll do is we'll get the top face for the family from the family SAT file, because and this was kind of annoying, but we can't just insert a SAT file and then get the face. It needs to go into a family, and then we can get the SAT file. The reason, or the face of that SAT file, the reason why we have to get the top face is because when we get the bottom face of the SAT file, which is like the what happens is it just flips. The ceiling comes in upside down. So it's easy enough to figure out the top of that plane, and then, or the top of the SAT file, and then just kind of figure out, okay, this is the top. We just need to place this, like 6 inches below that, which will give us the actual where it needs to be in space, instead of placing it either in the center or on the wrong side of the ceiling, if that makes sense. And visually, this will make a little bit more sense when we actually run the script. But that's all this is doing. And then finally, it takes those faces and then creates the curtain system. And then what we do here is we'll delete some stuff. So we'll delete the project families, so all those SAT families we imported, and then we delete the ceilings. And then we're left with only the ceilings from, or only the curtain system ceilings. So right here is the model. I'm going to run the script, and over here to the left you'll see generic models. What it's going to do is load in a bunch of families, and you'll kind of see that happening, and then you'll see it delete them. And this kind of runs a bit slowly, but it's faster than manually doing it. I am surprised, though, it does run faster than I thought. I did this on a model with 150 different ceilings, and it ran just fine. It was able to deal with that. So, but there's definitely ways you can optimize it, especially if you have like you're using, it's the same ceiling, same width, and everything, placed a bunch of times. You could probably optimize that in some way to only use one family instead of loading a different instance of the family each time. So I'm going to run it, and then it'll take a minute, and you can kind of see down here that it's loading in the families one by one. So you can see ceiling temp _1, and then 2, and what it'll do is it'll move all the way up to 6, and then at the end of the script what it's going to do is delete those ceilings. So you can see here now we're only left with these. You can see the points, so the insertion point, which is here, and then here's the family point, or I mean the centroid point. And then down here you can see what we're doing here to calculate the difference. So it looks at this starting point. So this is 0, 0, and then, or sorry, these are all being inserted at 0, 0 in space, and then we figure out the centroid, we figure out the distance between the insertion point and the center point, and that distance is what we use to subtract from the centroid of the element that's placed in real space, or the ceiling that's placed in actual space. We deduct that, and then we get the actual insertion point where that SAT family that you saw loading up needs to be placed at to get the ceiling and or the SAT family into the right location for us to actually apply that curtain system to. So you can see that here. So hopefully that kind of makes sense, and what we'll do is we'll just jump back over here and we'll look at what's going on. So here we figure out our ceilings, and then in this case we only had these ceilings, so it grabbed all of them. Down here we figure out the thicknesses and stuff, and we do a little bit of math to kind of figure out where in space those need to go. And then I think over here is probably going to help you better understand how it placed it in space if you didn't get it. So we have it's placing at 0, 0. We got the element geometry. We have the solid centroid, and then all we need to do is see, okay, the centroid is at 31 x, so this is in the x, and then in the y it's 53. So we just take those two values and we subtract them. So we do the real space. So this CLX is it's the real, and I think I used abbreviation like current location of the ceiling in real space. So CLX is, and all we do is subtract, since this CLX, the input is the center point. So that's what these x values are. They're the center point of the geometry. And so we subtract this, and we get an output of the insertion point for the files, or for the different ceilings. And so right here is just the list of the z minus thickness. But if we look over here, you can actually see the points after the subtraction. So you can see this is the x. We have 64 there. We have 64 here, 53 here. Up here we have 31, and then 53. We subtract those numbers from 50 or 64 and 83, and we end up with 32 in the y, and then 29. Or sorry, 32 in the x, and then 29 in the y. So that is kind of what's going on there. And if that doesn't make any, if it's still kind of difficult to understand that, just sit down and kind of just walk through this step by step, and just see how the information kind of flows from node to node, and then just play around with it and try different things and see, okay, if I change this, where does it show up in space? Is it different? Stuff like that I think is really helpful in just visually seeing and just messing with it yourself. You can see here it deletes those first instances, the ones that are placed at 0, 0. Over here, this one is just getting the face, which I didn't talk much about this, but all this does is it retrieves all the faces, and then I get the surface perimeter curves, and then I figure out the start point, and then I figure out the point in the z, and then all I do is I flatten it, and then I figure out the maximum items. And I do a level 3 flatten, so it still has the structure. It's just putting them in a nice structured list. So you can see here there's 6 of them because we have 6 ceilings, so it's still a structured list. But after that, I just figure out the maximum of each of those lists. So in this case, they're all at the exact same height. So 0 to you can see just 8.0 and on. You can see that for each one. It gives us the maximum, which we're just using to find out where the face is in space. And then what we do here is we'll just filter out that information, and then it'll give us a list of surfaces. And I think what's really important is if you sit down and look at the way that the levels are set up and the way that lacings apply to it, I think that's a great way to better understand Dynamo. I think understanding that is a foundational thing. Just understanding list, I think, is incredibly important. And so definitely take a look at how that information flows. But at the end of it, what we get is the necessary surfaces. So you can see there's 6 surfaces there, but if we go back over here, there's 49 surfaces. So there's a lot of surfaces that we don't need, and we end up with just 6 over here at this end. And then those are the faces that we're using to place the curtain system on. And then from there, we're just deleting all the extra stuff. So all the families, project, I just call them project families, but they're just families that are inside the model, and then are in the actual project. And then delete the ceilings at the end. So if I minimize this, you can see we don't have any of those families in here anymore. We don't have any ceilings in here. It's just the curtain system. And then the model's just left with this. So it keeps it clean. It also allows folks to, if they want to update it, they just create a new ceiling and they can rerun it. It creates it. But again, take this, see if it applies to you. If it doesn't apply to you, tweak it and apply it in a different way. Take things out. I mean, do whatever you want. But let me know if there's anything you need help on, or if you have any trouble using this script. But I appreciate you watching. I'll see you in the next one. Make sure to like, share, and comment if you want to. But I'll see you in the next one, guys. See ya.